Alright guys, welcome to 3.2 of Math 0314. We're going to be talking about solving systems via substitution. So, what I want to talk about in this video here is one of the most important ways of solving systems of equations. So last time we talked about graphing, but graphing typically, if you have just paper and pencil, is not the most efficient way of solving these problems. What's a better way is to use what's called substitution. And in substitution, what we do is we try to isolate a variable. So, take a look at these two equations and ask yourself, out of the two equations, which letter would be the easiest to isolate and in which equation? So hopefully you said the second equation, it would be easiest to isolate the y. Why? Because if you subtract 6x from both sides, y equals negative 6x plus 6. Which means I can take this value here and substitute it into this equation. So note, this equation will be the same thing, except instead of calling it y, we'll call it negative 6x plus 6. Why is that okay? Well, because we just said y is negative 6x plus 6. So instead of calling it y, I can call it negative 6x plus 6. And from here, all I need to do is solve. So we distribute, and we'll get 3x plus 12x, watch the sign, minus 12 equals negative 7. Solving the equation, we'll combine like terms. We put these two together, get 15x minus 12 equals negative 7. We're going to move the 12 to the other side. I'll add 12 to the other side. And we will get 15x equals, what is that, 5? And then to finish it off, we're just going to divide through by 15, and x will be 1/3. Now, if x is 1/3, then I can take this value of x equals 1/3, and I can substitute it back in here, and I can solve for y. So, space there. Give myself a little more space. So, substituting it back in, we get y equals negative 6 times 1/3 plus 6. Hopefully you're not intimidated by the, let me change the color here, sorry, the 1/3, because we know 6 divided by 3 is 2, so this is just y equals negative 2 plus 6, which means y is equal to 4. So my final answer is going to be 1/3 comma 4. So again, what you do is you isolate one variable. We chose y here to isolate because it was the easiest one. Substitute it back into the other expression, or other equation rather. Solve, you'll get an x value. Take that x value, plug it back in, and that'll produce your y value. And you can take your value of 1/3 and 4, and you can substitute it back into both equations to prove to yourself that it's true. Now what I did, and kind of extrapolating from what we've talked about before, so I went ahead and I graphed it. If we see here, we can see the graph, we can see where they're intersecting, and we can see that in fact they actually do intersect. 0.333 is 1/3, so they do intersect at 1/3 and 4, which is what we got. So those values make sense, and so our answer makes sense. And so you can see, obviously if you have a graphing utility, you can just simply graph them and find the point of intersection. But with by hand, this is the mechanism that we want to do. Alright, let's keep going. Okay, so number 2. So pause the video right now, give yourself a second to think about what you want to do here to solve this. So hopefully you've paused the video and you've had a shot at this, you've thought about how you want to solve it, and maybe you even try to solve it. This one is interesting because there's two ways we could approach this. We could move 3x over and then I'll get y by itself, or I could move negative 2y over and get x by itself. And either way you're okay. I'm actually going to choose the latter. I'm going to move 2y over, and I'm going to get x equals 12 plus 2y. And the reason why I did this is that by moving the 2y over, I keep this expression, I keep both sides of the equation positive. Okay, so now I know that x is 12 plus 2y. I take that value of x, I substitute it back in here. I get 3 times 12 plus 2y. 2y plus y equals 8, and just continue to solve like a regular equation. So I'll distribute, and when I distribute, I'm going to get 36 plus 6y plus y equals 8. I'm going to combine like terms, so 7y here, everything else is the same, 36 equals 8. Subtract 36, 7y equals negative 28. Divide through by 7. Y is negative 4. I'll take that y value of negative 4, we'll substitute it in here, so x is equal to 12 plus 2 times negative 4, which will give me x equals 12 minus 8, which means x is 4. So the final solution is 4 comma negative 4. If we look at the graph, we can see that that value of 4 negative 4 makes perfect sense. So, cool beans, moving right along. So, take a look at number 3. Think about how you'd want to go about solving it. If you want to be adventuresome, go ahead and solve the problem. And I'm assuming that you've done that, and so let's talk about it. So here, clearly, I'm already telling you x is equal to negative 1/3 y plus 2, so it makes sense to substitute that value in. Alright, and solve like normal, distribute. So we'll get, now remember, negative 3 times negative 1/3 is going to, negative times a negative is a positive, 3 times 1/3 is 1, so we're left with y. Negative 3 times 2 is negative 6. Plus 4y is 9. Let's combine like terms, so we're going to put these two together. We're going to get 5y minus 6 is 9. We'll move the 6 to the other side. 5y is 15. And divide through by 5. Y is 3. Once more, we take this y value and we substitute the y value back in here, which will give me x equals to negative 1/3. Y is 3, so 3 plus 2, which means x equals negative 1 plus 2, which means x is 1. So the answer is going to be 1 comma 3. And we can see here I graphed it, and we can see that the value of 1, 3 does in fact exist there when the lines are graphed. So, making sense? Let's keep going. So the next one, x equals 2y plus 3, contrasted with 4x minus 2y equals 0. Go ahead and pause the video if you haven't done so already and try to solve this. I'm going to assume that you've done that, and let's tackle this together. So we're going to take this value of x, we're going to substitute it in here. We're going to get 4 times 2y plus 3 minus 2y equals 0. Same thing we've been doing, distribute. 8y plus 12 minus 2y equals 0. This will give me 6y plus 12 equals 0. Move the 12 to the other side, so 6y is negative 2. Finish it off by dividing by 6. Y equals negative 2. Take that value of y equals negative 2, plug it back in here, so we'll have x, let me pull up a little bit, x equals 2, I said y is what, negative 2, times negative 2 plus 3, so x is negative 4 plus 3, so x is negative 1. So, once again, we can see that our answer corresponds with the graph. Great, let's keep going. Alright, next up we have x equals 2y minus 4, and then we also have negative 2x plus 4y equals 6. So go ahead, pause the video, give it a shot, see if you can figure out how to do it. Should be more of the same. And now let's do it together, if you haven't done so already. So we're going to distribute into x. It makes sense to plug in 2y minus 4 for x, because x is already isolated. And then we solve. So we'll distribute. We'll get negative 4y plus 8 plus 4y equals 6. Now, here something interesting happens. So the negative 4y and the plus 4y cancels out, and I get 8 equals 6. So when we look at this, we get 8 equals 6 again. And so what this means is that the lines do not cross. This is what we call, from 1.1, a contradiction. And this means there will never be a solution that works. So let's look at this from a graphical perspective. So when we look at the graphs, we can clearly see that the lines, both of these lines, are in fact parallel. So the graph will never cross, and hence there's never a solution. So that's kind of nice. One other way to notice this is that notice that if you get y by itself in both equations, so if I add 4 over and divide by 2, I get 1/2 x plus 2 on negative 2x plus 4y equals 6. I'm going to have to do this over down here. Negative 2x plus 4y equals 6. If I get y by itself, I add 2x. I get 4y equals 2x plus 6 and divide by 4. I'll get y equals 1/2 x plus 3 over 2. Okay, I want you to notice that the slope is 1/2 here, and the slope is 1/2. And what that means is that these lines, right, have the same slope. So if they have the same slope, yet different y-intercepts, 2 versus 3/2, right, then what that means is that the lines are never going to, are of course never going to cross. So, so realize that sometimes if you don't have to get a solution, right? Let's look at the next one. So go ahead, try this one, and see what happens. Okay, so hopefully you've tried this and you're ready to talk about it, and let's see what happens. So I'm going to take this 1/2 x plus 1, because y is already isolated, and substitute into the other equation. I'm going to go ahead and distribute. Negative 8x minus 16 is what we end up getting. Hopefully that wasn't hard for you to do, right? Well, half of 16 is 8. And what we're going to see here again is that the 8x and the negative 8x cancel out, and we get negative 16 equals 3, which means we have a contradiction, which means we will not have a solution. So I don't know if I stated that explicitly in the last one, but there is no solution. The answer is no solution. Right? And, or, again, we could use that as the empty set to say the answer does not exist, or we could use that to represent the empty set, or sometimes it's called the null set. Okay? So the same thing would be here. I'm just going to write no solution. Okay? And we don't see an example here, but we could, I didn't have an example from the book, but we could see something like this. Okay? And in this situation, what you're going to notice, I mean, you can just even look at the two equations. This second equation is double the first, which means that they're the same equation. So if I solve this, let's say I get x by itself, and I take this x value and I substitute it back in here, what we get is 2, 6 minus y plus 2y equals 12. When I solve this one, the negative 2y and 2y will cancel out, and I'll be left with 12 equals 12. Now, this is true, and what this means is that the two lines are on top of each other, because if you divide this equation by 2, you can clearly see it's the same equation, right? So when this happens, that means the lines are on top of each other, which means it's everything. The solution is all reals. All real numbers. Sometimes you'll see it as negative infinity to infinity. Sometimes you'll see the symbol r. There's a lot of different ways we can represent it. So that is it. So hopefully that makes sense. Substitution does take a little practice. If you need more examples, let me know and I'll show you some more examples. But in the meantime, I'll just see you in the next video.